All right, so I'm assuming we're live now. YouTube is saying so. So we're going to see how this goes. This is my first live stream. Apologies if something goes horribly, horribly awry. But my name's Jamie Duncan. We're right at 2:30. I think we have a few seconds until 2:30. So we're going to, right at the top of the hour, we'll get going into Kubernetes the hard way. We're going to give it just a couple of minutes. I wish I had some music. I should have some music here. All right, lesson learned. All right, we're right at the top of the hour. Tested this out with a coworker, running through and having some discussions, not a ton of discussions. Hopefully, we'll add a little more flavor. Going through the labs that we're going to go through today, which are the first 4 labs from Kubernetes the hard way. And I have links and everything here in just a couple of minutes. In fact, let me go ahead and bring up the docs page. So the documents page should be giving you, here's the link. There's a little bit of lag, so it's freaking me out a little bit. I'm going to have to get used to that. You can grab the URL off the top. I'll also drop the URL in the chat real quick. And this is what we're going to be working off of today. The links to the actual Kubernetes the hard way docs from Kelsey Hightower are in here. And what I've done is taken several of the labs and condensed them down. Expanded out on some things that, looking through them, I thought was important, and boiled them into a Cliff Notes version of 3 or 4 labs at a time that I'm going to do over the next 3 or 4 weeks. And at the end of October, the end of Kubernetes Appreciation Month, we'll have essentially gone through all of Kubernetes the hard way, and these docs are going to be out there live so we can add to them. They're also out in GitHub. I'll improve the links and everything as we go. If you look down, the persistent links and everything, the actual links to Kelsey Hightower's docs in GitHub. If you are a Googler, there is an internal link, what we call a Go link. This stuff is also in GitHub, at the GitHub link there in my repository. And then I've broken each of the 4 sessions into its own document. Session 1 and Session 2 have been done and tested. Session 3 and Session 4 I'm working on now, just to make sure everything works the right way the first time. And I said that, and of course this is now a kiss of death. So I'm sure something is going to break. So we're going to go through 4 labs today. We're going to go through the prerequisites. We shouldn't take too long. Also installing the client tools. If you're using GCP to do this, Cloud Shell has most of the tooling installed for you. It's the free VM that you get with access with your GCP account. Makes a lot of this easier. So you don't have to stand up a Bastion host. You don't have to install a bunch of stuff on your corporate laptop or your personal laptop. So I'm going to be using Cloud Shell for all these labs. A couple of oddities about it because it's not a persistent VM, but they're actually pretty minimal and it's a pretty good thing. So we'll go through prerequisites. We'll install client tools. We'll provision the infrastructure that we're going to be using. We're going to be building an HA control plane, which is 3 control plane nodes and then 3 application nodes. So we'll have 3 nodes that workloads can run on and 3 nodes that are going to be the control plane for Kubernetes. You'll see in the documents, I say application node. You'll also see worker node in the documents. Those terms are interchangeable. Someone pointed it out to me, and it's just what I've learned. I've always just called them application nodes. There's no particular difference. It's just different terminology from different people at different companies. So the first thing we have to do, assuming you're using GCP, and these steps are going to vary if you're on Amazon or if you're doing this in a VMware lab or you're doing it somewhere else. I'm assuming you're going to be using GCP to do this. So I'm assuming you are going to need to configure all this stuff. So this is all in there. Understand that if you're using a different platform, the steps are going to change a little. So we need to make sure we're running version 301 of our software. I'm going to hop over here to the terminal real quick. Clear this command out. Gcloud version. You can see that I'm running version 311, which is more than 301. So I'm good to go there. And so because I'm on a new Cloud Shell instance, the way Cloud Shell works is it is an ephemeral VM. And my home directory has some persistent storage, so I'm able to store stuff in there and use it and persist it over time. But the VM itself, the RAM, and most of the operating system is spun up on demand. So inside my Cloud Shell, I'm going to connect over to my Cloud Shell here in just a second. And it just dawned on me I need to run the same command inside my Cloud Shell, a Gcloud version. I'm going to have to log in once I connect to my Cloud Shell instance. So let's go ahead and do that. That was that command that I cleared out a second ago. Gcloud Alpha Cloud Shell SSH. You can see this is actually spinning up a machine, and this just takes a handful of seconds for it to get spun up for me to connect to. Go. Hey Andy, how you doing, man? So we're building Kubernetes from scratch the way you like it best, right? All right, so in that amount of time, I've spun up a free VM, and I've actually got a couple of scripts that run at the beginning of when I launch a Cloud Shell. It takes a few extra seconds, but it's doing all of those now. All right, go. And you see, I've also got mine by default. It uses Bash. I've got mine configured to use Z Shell because I use Z Shell everywhere. And all of that can be persisted in your Cloud Shell from one instance to the other. It's actually pretty slick. So just to double check, Gcloud version, obviously we're going to keep these up to date. I'm using version 312. I'm good to go there. And I need to log in. Gcloud init. And I'm just going to take the existing configuration and apply new settings to it. Do I want to log in? I do. And then I have to go out to a browser window and click this. I don't love this process, but it's just going to have to happen. And I'll clear my screen here in just a second. Hopefully no one types that fast. There's just not a way around it. All right, so I'm now good to go. I have created an empty project ahead of time. Kubernetes The Hard Way, J. Duncan prod. And I'm good. I'm now logged in. All right. And that's all it takes to get all set up. Let me get back to the right window here. All right, Gcloud init, Gcloud auth login. Just did that. Double check, make sure I've got the right session. Oh, no, I don't need to do that twice. Apologies. But I do need to go ahead and set my regions and zones. Gcloud config set compute region. I'm going to be using our US East 4 region, which is the one up in Northern Virginia. So I can copy that right out of the lab. US East 4, and I'm going to be using zone A. Done and done. And then, actually, I just did that wrong. Yay. You got to love it live. My zone is US East 4. And then my region is US East 4. My zone is US East 4A. So I want to get those variables set the right way. That way everything gets deployed in and done for me. So session handling, we're not going to need it this lab, but when we configure etcd in session 2, we are going to need to be able to send commands in parallel to multiple servers. We don't want to have to go into server 1 and configure it, go into server 2 and configure it, because humans are human and we're going to mess something up. So we're going to use Tmux to do that. If you're using Cloud Shell, Tmux is installed by default, so you don't have to do anything. It's there and ready for you to use. If you're using a different platform, make sure Tmux is installed. Any modern version will do. And we'll actually just open up 3 panes in Tmux and connect to our control plane and then to our application nodes and get it all configured and squared away. That's the first lab. So we're starting off nice and easy. We're probably going to be hopefully we'll be a little long on time here. I don't think we're going to take 90 minutes today, but like sessions 2 and 3 later this month, in particular, once you start getting into actually configuring Kubernetes itself, we probably will need the full 90 minutes, but we're going to start off a little easy. So we've got our we've got our SDK configured. Now we need to configure we've talked about session handling just a little bit, and we'll talk about that in more depth when we actually take advantage of it. What we're going to be doing now is installing some infrastructure tooling. We're going to install Cloudflare's SSL tools. They're really easy to use. You can create a certificate authority quickly. You can get everything. Then you can turn around and sign all the TLS certificates that you need to sign to actually use Kubernetes. I think I counted it up, and there are 9 or 10 different certificates that we're going to create today. They're going to get shuffled out to the different systems and used to encrypt communications between all the different services for Kubernetes. It's going to be pretty, that's kind of the cool part of Kubernetes the hard way, is that we've all gotten so used to having an installer for Kubernetes, even though the technology is only 5 or 6 years old. What Kubernetes the hard way does, the first thing we're going to do is build a bunch of TLS certificates, which really kind of drives home that all the communications in the control plane, talking to the control plane, or the control plane services talking to one another, or you interfacing with the API, has to be encrypted by default. The system is designed for encryption. And we're going to be using 2048-bit encryption in our TLS certificates. So good, solid, strong encryption is the de facto standard inside Kubernetes. That's an important thing to think about. Like, when we use kubeadm, or we use KOps, or we use Minikube, or whatever we use to spin up a test cluster, or if we just go grab a GKE instance from Google or an AKS instance from Azure or Amazon's EKS, we kind of forget all of the work that goes into the automation there. And we're going to be using all of that over the course of this lab. So the first thing you got to do is create a bunch of certificates. And then we're going to, in session 2, we're going to create a whole bunch of configuration files. And then we're going to actually deploy etcd, and then we'll actually deploy all the other services. So hopefully, for me, it's been a good refresher because I've just gotten away from that for so long. I just haven't needed it, haven't needed to use it for a whole lot of time. So let's keep going. So we need to install our PKI infrastructure. Got instructions for OS X. Cloud Shell is a Debian Linux-based system. So we're going to be able to use Linux for there. But OS X instructions, if you're using it, there's also brew install cfSSL. I'm going to use the Linux instructions. It's quick and easy. Should be able to copy paste. Hit enter. Done and done. Just grabbing the right window. There we go. Then I make everything executable because these are just pulled down fresh off the internet. Obviously, none of this is fit for production because you're just pulling random binaries off the internet. But, double check. Step 3 is going to be if you're using Linux, like if you have a Bastion host or just a Linux laptop. For Cloud Shell, there are some special instructions. And the reason these special instructions are there is because in Cloud Shell, user local bin is ephemeral. It's reset every time. So if I put something in user local bin, and then tomorrow I start a new Cloud Shell instance, it's not going to be there. But my home directory is persistent. So I can create a directory named bin in my home directory, add it to my path variable, and now my SSL tools will persist across a reboot inside Cloud Shell. So I'm going to make a directory called home bin. And I'm pretty sure that's already there. Yep, there's my bin directory. So I'm not going to pull these down because I've already done this step in testing. They persisted, and there's no need to delete them. They're just there. They're already there for me. So make a directory named home bin, and then I set the path variable there. Export path equals path. Add my newly created home directory. Done and done. If I want to make that persistent, I have my bash RC or my ZSH RC or whatever RC file I use for my shell. I can add that edit to my path directory there, and it's done, and it works just fine. Then I move my downloaded files to my newly created home directory or my newly created binary directory, and everything works. I want to verify that. Can run cfssl version. Oh, I didn't. And then, of course, I've got an error. Oh, because they're not executable. Sorry about that. Chmod plus X star. Now, there we go. Now it's going to do what I tell it to do. So CFSSL version, I'm running version 1.4.1 just like I should be, and everything works. And then the JSON interpreter for it. I'm not going to go too deep into what these Cloudflare tools do. Essentially, what they are is wrappers around OpenSSL. They take JSON that I can create, and that's what we're going to be doing, creating some config files, and using those to generate a certificate signing request, and then signing it with the certificate authority that we create here in just a minute. So, not going too deep into it. It's pretty well documented. I think there's a link in the documents up above to the actual homepage of where everything lives. Should be good to go. So installing Coupe Ctl, and please don't say Coupe Ctl. Again, with OS X, you just download the OS X binary if this isn't already on your system. Again, with Cloud Shell, it's already on my system, so I don't need to do these things. But I am going to go ahead and verify that Coupe Ctl is the proper version. A little belts and suspenders. All right, I'm running 1.19.2. I need at least 1.18.6. So I should be good to go. That amount of drift isn't going to kill me for what we're doing. All right, that's all the tooling we need. That's it, easy peasy. I've got a thing to manipulate a bunch of SSL certificates, and I have Coupe Ctl. From that and the Google SDK, I'm going to be able to bootstrap an entire Kubernetes cluster. And then, of course, some binaries out on the internet. So the next step that we need is to go ahead and create our infrastructure. We're going to go ahead and spin up our systems. So let's get that knocked out. All right, provisioning, computing, networking. First thing we have to do is create some VPCs. We're going to put it all into its own VPC. We're going to call that VPC, that network, Kubernetes The Hard Way. So Gcloud Create. I have to enable an API because this is a brand new project that I created and haven't done anything in before. So it's just going to take a couple seconds for that API to be enabled. We'll let it get it done. All right. And if you haven't, just to be on the safe side, the section of the documents that we're on, just bring it back to here. We're in the VPC configuration in the section provisioning, compute, and networking. I'll try to remember to bounce back and forth so you can see, because I'm just literally going down through these labs. So Gcloud Compute, create everything. It's enabling the service. It's going to take it just a minute or so. Done. Now my service is enabled, and it'll go ahead and create my VPC for me. All right, that's done. My output, I have samples of the output. Everything looks like it should work. Everything looks like it should. Oh, I see a typo that we'll have to fix real quick. We're using HackMD. So again, this is completely live. So I'm going to hop over and actually edit this markdown to fix this. You can see here, this should not be inside my source code. So I've just got some backticks missing. So I'm going to hop over to the actual markdown. HackMD is one of the best tools I've ever seen. I can actually hop straight over in the browser window, scroll down to where my typo is, installing PKI infrastructure. Now I'm into that section about Cloud Shell, verifying everything, installing Coupe Ctl, provisioning compute and networking. All right, so here is cluster networking, VPC configs. All right, so here I am. So Gcloud Compute, here's the output. And if you see, and then I need a set of backticks here. And that should fix my problem. So if we go back and look at it, it now looks better. Hurrah! All right, so instances on this network are not going to be reachable until firewall rules are created. By default, GCP keeps everything completely locked down. So we're going to create some firewalls. All right. Output. Gcloud Compute firewall rules create Kubernetes the hard way. So this first network, or this first firewall rule, is going to allow completely unfettered communication. So all TCP, all UDP, and all ICMP on the internal networks. So source ranges 10.240.0.0, and then 10.200, which we didn't actually create. We haven't created in our subnet, but we're going to talk about here in a few minutes. I think. Oh, I actually skipped a step. Apologies. I was in my thirst to scroll. I forgot to create the actual subnet. All right, so here we're creating a 10.240.0.0 class C/24 subnet. We're going to put it on this newly created Kubernetes the hard way network. Sorry about that. All right, this is going to be the network that all of our infrastructure lives on. So all of our control plane nodes and all of our application nodes are going to have a 10.240.0. something address. So when we create our infrastructure here in a few minutes, we're going to reference that. All right, by default, GCP doesn't allow anything to talk without a firewall. It's a completely restrictive firewall set by default. So the output is created. So we're going to create some firewall rules. The first one is to allow anything internal to communicate freely. We're not locking down stuff that way. If you want to lock down stuff that way inside a Kubernetes cluster, yes, your network security team can do whatever they want to do. But inside the cluster, we would be using network policies. And network policies are a little out of scope for these labs, but they are not out of scope for the CKA exam, the Certified Kubernetes Administrator exam. And they're not out of scope for what you should be doing for any kind of Kubernetes cluster that is important to you. All right, so Gcloud Compute, again, that 10.240 network will allow all TCP, UDP, and ICMP. And this 10.200 network is our pod network. And we'll talk about it in a little bit once we actually start leveraging it. But the pod network inside GKE clusters, or inside, the way we do the networking configuration, the way we do the networking config inside GCP, we're going to take advantage of the same way GKE uses it. And we're going to do some routing and stuff and not have a traditional SDN. So we have we have a GCP plugin for Kubernetes that we're going to use. So we actually can see the pod network in a slightly different way. So if you're used to Kubernetes where you're using like Calico, which is the default one, it's going to look a little different. It's going to feel a little different, but it'll work, I promise. It's just kind of a neat thing. So we have to define that network to allow communication between all pods without any kind of restrictions. It's just odd that we're referencing a network that hasn't been created yet in our firewall rules. All right, creating firewall. Done and done. All right, your output should look something like the example. Now, from outside, we want to be able to SSH and talk on the proper ports. So we'll create a second firewall, much more restrictive, obviously, only allowing 2 TCP ports and ICMP from the outside. TCP 22 is obviously SSH. TCP 6443 is what we're going to use to talk to the Kubernetes API server. So those have been opened up externally. All right, and that's done. Later on in a different session, we will be creating a GCP load balancer. But the first thing we need to do there is to allocate a static IP address for the external load balancer. We're going to go ahead and get that now and allocate it because we need to reference it in some configuration files and in some certificates. So we'll create the load balancer when we need it, but we're going to go ahead and grab its IP address for us now. All right, that's done. Verify our firewall rules are in place. All right, Gcloud Compute firewall rules list, and I filter on our network. I've got two. One of them is allowing TCP 22 and TCP 6443, and the other one is allowing all TCP, all UDP, and all ICMP. So our network, our firewall rules got created on our network. And then we'll go ahead and make sure our static IP address got created properly, even though we got confirmation, a little belt and suspenders, never hurt anybody. All right, and that IP address, and yours is obviously going to be unique, but this IP address is going to be what I'm going to use for our load balancer to access our Kubernetes API server. All right, so that's all the networking configuration we need to get going. So we created a VPC, we created a network on that VPC, and then we created a couple of firewall rules applied to that network and on that VPC, applied to that subnet to allow external access on port 22 for SSH, and on port 6443, which we'll use for the Kubernetes API server. And then we also created an internal firewall rule to allow anything to talk to anything, so not to put up any sort of grief there. So to allow unfettered internal communications. Again, none of this is fit for production. Please don't take these rules and go and do this process on a Kubernetes cluster, and then when you get hacked, come yelling at me. Not fit for production. Again, this is very much experimentation. Our goal is to take Kubernetes to bootstrap it from the smallest pieces possible, and to do it by hand to see how it works. All right, so we've got our VPC, we've got our network, we have our network's firewall rules, we have a static IP allocated. So we've got everything we need on the networking front, for at least for now. The next thing we're going to do is create some compute nodes and some control plane nodes. All right, we've got this in a real simple for loop. So for I and 0, 1, 2. So we're going to create a something 0, 1, 2. The first command, the first for loop creates our controller. So we'll have controllers 0 and controller 1 and controller 2. They're going to have 200 gig disk. They're going to set up IP forwarding. That's a requirement for the way we're setting up our SDN, our network, inside for our pod network. They can IP forward. We're going to be using the Ubuntu 2004 LTS server config, or 20.04. It's good. It's easy. It works well with Containerd in particular. We're going to be using Containerd as our runtime. E2 standard 2, so 2 CPUs. Private network, we're going to attach it. So we're going to have this, the controller 0 is going to be 240.0.1. So .10, .11, and .12 on our 10.240.0 network. Scopes, compute read-write, storage read-only. So this is all just kind of standard issue stuff. We're going to put them on the Kubernetes subnet that we just created. And then we'll tag it as a controller and as a Kubernetes The Hard Way instance. So those are just tags that, and we're going to we might leverage those later or pull them into logging and metrics and all that kind of fun stuff. So go ahead. Drop this for loop in. All right, and we'll see it loop up 3 times. I gave it the asynchronous option, so it's not going to wait for each one to get going, which is always a good thing. All right, our output should look just about that. All right, 3 application nodes as well. Again, we're going to give it the same options, same 200 gig disk, same operating systems. Our application nodes are going to be 10.240.0.20, 21, and 22. They're going to be on the same subnet. And we're going to give them the worker node tag, which is just about the only difference between the two. All right, and just in case you're keeping up live, I'm in the cluster compute section, cluster compute nodes inside session 1. So we're in the cluster compute node section. We've already ran the first for loop. Now we've run the second for loop. And then we can verify that all of our instances are running. So step 3 there. And we should see 6 servers. And there they are: controller 0, controller 1, controller 2, worker 0, worker 1, worker 2. They've got the IP addresses we expected them to have: 10.240.0.10.11 and .12, and then 240.0.20.21 and 22. Everything is up and running. So we have, in this section, we've created our VPC, we've created our subnet, we've applied firewall rules to our subnet, and then we have created 6 servers for our Kubernetes cluster on that subnet inside that VPC. Ta-da! All right. Does any of this, if any of it doesn't make sense, just give a shout out on the chat. But this is pretty straightforward stuff. The next section, I think, is probably the coolest. Well, before we get to that, we're going to go ahead and make sure that we can SSH to these servers. So Gcloud compute SSH controller 0. We're going to use the Gcloud command there because it manages all of our SSH keys for us, which is pretty slick. We don't have to worry about known host files, and we don't have to worry about SSH copy ID or dropping our public key in the right place. The Gcloud compute command, the SSH parameter, will take all of our keys, keep the private key safely inside Gcloud in our SDK, and lets us pull it out on demand and get to the server that we need to get to. We also don't have to remember the IP addresses. We just have to remember the name that we gave it, which to me is worth the price of admission. They're just taking a quick look at something. Firewall rules list. All right, should be good to go. We have port 22 open. It's going to pull it. So it's going to go ahead and create a private key for me because I've never used one before. And I'm on controller 0. I run a host name. I'm on controller 0. So I've provisioned my infrastructure and I have connectivity to it in all the ways that I need to have. Exit gets me out of there and I'm back to my Cloud Shell server. And I'm good to go. Now we get to the heavy lifting of this particular session. So we have to create a bunch of TLS certificates and we have to create a certificate authority to sign them all. So we're going to use the Cloudflare SSL tool that we downloaded earlier. So the first thing to do is create a certificate authority, a CA config JSON file. Take all of this out if you want. It's going to have an expiry of 8,760 hours. I haven't calculated out how many days that's going to be. We're going to use it for signing. We're going to use it for key and cipher, server auth, client auth. So we can feed all of this into this tooling, and it's going to take care of all the OpenSSL stuff for us. In mine, I'm going to go ahead and make a directory called Kubernetes The Hard Way, KTHW. Oh, it's already in there. So we'll make 1, 2. Just to keep all my files in one place. The commands in the labs are EOF or here docs. So you don't have to use Vim or anything. You just paste it in. It creates the file for you. Just to go ahead and make sure that that works. Everything looks good. So that's our certificate authorities config JSON file. And then we create our certificate authorities CSR JSON file. Feel free if you want to, wherever you live, to go ahead and swap out those things. I think if you look in the Kubernetes The Hard Way docs, it actually has Portland, Oregon, which is where I think Kelsey Hightower lives. I swapped him out to Raleigh, North Carolina, which is where I'm at, just because I thought it was funny. All right, now we've got those two JSON files. We can use this CFSSL tool to generate our cert and create everything. So it processes the JSON, and then we pipe the JSON into the CFSSL JSON tool and actually create our certificate authorities. And the certificate authorities are just special keys. It's like the private key that we use to sign everything else. Paste that in. So now we've created a 2048-bit certificate authority that we can now use to sign all the other certificates that we need. If we want to go ahead and verify that, there we are. Can scroll up a little. There it is, North Carolina, Raleigh, Kubernetes the Hard Way. All the stuff is as it should be. All right. So we now have a certificate authority. We've created a bunch of files. I look in my folder. There they all are. But ca.pim and cakey.pim are my certificate authority that I'm going to be using for the rest of these sessions to sign everything that I need to have signed with encryption. Excuse me. So the first file we need to create is for the admin user. So if you ever log into a Kubernetes server, typically the root user on the control planes, you can log in as system:admin. Well, this is the certificate that is used for that. So we're going to go ahead and get that created. And again, it's just kind of stunning. Like all of this is automated for us using kubeadm or using whatever installer that we're using. But going through and doing it all one at a time, while it's not practical, it does help you appreciate, number one, appreciate what all that automation is doing. But number two, understand where all this stuff is coming from, and it's not just a random configuration file or a certificate that you drop in a config file because someone from tech support or on Stack Overflow told you to do it. All right, so that one's created. And if we look at our files, we should now have admin key.pim and admin.pim along with the CSRs. We can verify that. And this is the last one of these I'm going to verify on this session. I mean, they all work. I'll go back and double check them. But just as long as we have valid output, our key is valid and functional. All right, now we need to create our Kubelet certificate. So this is the TSL certificate that the Kubelet uses on each node. And if you haven't, I don't know where people that are listening or will ever listen are in, I don't know where anyone is in sort of their knowledge, the scope they have of Kubernetes. But I don't want to get down into the weeds too much on architecture design. That's why I purposely didn't include an architecture diagram. But the Kubelet runs on, and it's a horrible name, I know, but the Kubelet runs on each node that is being managed by Kubernetes. So either on all your application nodes, and then sometimes, depending on how you deploy it, on your control plane nodes as well. The Kubelet is the process that communicates with your container runtime. So if you're using Docker as your container runtime, the Kubelet service runs, and then when the control plane, you tell the Kubernetes API that I need a new application deployed, a new pod deployed, the control plane talks to the Kubelet service on the node that it decides that service should live on, and then the Kubelet in turn talks to the container runtime and spins up the actual pod, the containers for the pod, and then reports that state back to the API server. So the Kubelet is essentially the Kubernetes agent running on each node in your cluster. And so all communication between the Kubelet and the control plane is encrypted using the certificate that we're creating here. Oh, get out of that one. So that's why instead of just a single file, we're putting this inside a for loop. We have to have a name for each one of our kubelets, or the name in our certificate has to be unique for each node, each application node when it is, when it's attached to when it communicates back up to the API server. So we're actually going to create all three of the certificates for all three of our application nodes with one quick for loop. And you see here that instance, I'm actually system, the name that is the certificate name, the canonical name in the certificate is what's used to identify each kubelet coming in. So that canonical name, we're going to put in there, parameterize it inside our for loop so that each certificate gets to the right server and everything happens nice and quickly and easily. All right, and then you'll see there's a little more stuff in here we're doing in this one. It's a little more complex. We're also gathering the external IP address of our, which is the one that we created earlier, or the external IP for our, I'm sorry, it's not it. This is the external IP address for each of our nodes and the internal IP address for each of our nodes, because we want them to be valid host names for our application nodes. So under the host names parameter, when we actually generate the certificate, the instance, so it could be worker 0, worker 1, or worker 2, or the IP address, the external IP address, or the internal IP address are all valid host names for this TLS certificate to exist on. So again, none of that, it's all stuff that we do every day in this world, out in IT, but just having to think through, okay, I'm using a TLS certificate to identify a service running on a node to my control plane. I then have to stop and think, all right, so I'm going to use the canonical name. Oh, and the host names have to be valid. And I have to do all of that for every node I add to my Kubernetes cluster. And just thinking through. So now, like, well, how does the kubelet know which server it is talking to? Well, it's the canonical name in the TLS cert. It's just a good thing to know when you're figuring out how Kubernetes works, or when you're more importantly having to figure out when it doesn't work the way it's supposed to. So this is a big long for loop where I'm actually creating all my CSRs and then generating the certificate for each of our nodes. So it takes a second or two to run. Excuse me. All right. So if we look in our new directory, we see there worker0 key.pem and worker0.pem. And then the same for worker 1 and 2, along with the CSR files that we created. So those are going to be for the kubelet. All right. Then we create a certificate for our Coupe Controller Manager service. So Coupe Controller Manager is a control plane service that actually runs all of the manages all the controllers. And what a controller is in Kubernetes is how work gets done, is the easiest way I can think of to explain it. But there's a controller that understands what a pod is. So there's code that defines a pod in Kubernetes, and that code is executed by a controller. There are also controllers to validate data, to mutate data, to make changes to data, to set default values, to do all sorts of stuff. So there are lots of controllers that that are executed inside your Kubernetes control plane to make sure everything is as it should be from a security and consistency perspective. And this service, the Coupe Controller Manager, is the thing that makes sure all of that happens properly, is what executes and manages all that code. All right, so we'll create that file and then generate our cert. Done and done. All right, and now our Coupe proxy. Lots of people get confused about Coupe proxy. Coupe proxy is not a proxy. Like, you can't swap out Coupe proxy. You can't swap out Coupe proxy for a different ingress or a different way to communicate with your pods. Coupe proxy runs on all of the nodes, although it's the same services. It doesn't have to be unique per node like the kubelet does, but it runs on each node, and it is the interface between Kubernetes and the networking stack that you're using. So we'll go ahead and get this certificate created. Done and done. Now our Coupe Scheduler. The Coupe Scheduler, you hear lots of people talking about the scheduling algorithm inside Kubernetes that decides where your next workload should go. Well, that happens inside the Coupe Scheduler service. The Coupe Scheduler, you can tune it to look for all sorts of things, all sorts of labels and affinities and anti-affinities, and get all of that so your cluster looks and acts exactly like you want it to. But all of that work is done by Coupe Scheduler on our control plane. So we create a certificate for it. And then the Kubernetes API server certificate, this one has to be a little bit different as well. Actually, yeah, it does. Because the Kubernetes API service is the one thing that's exposed externally. So we have to get that public address, the static IP address that we configured earlier when we were configuring our networking components. We have to grab it. So we're going to save that off as a variable. Make sure that that variable populated right. All right, good to go. And then that has to be added to a long string of various host names. So in step 3 in this section, we'll actually be creating a variable called Kubernetes host names. And it's all sorts of stuff. Kubernetes, Kubernetes.default, Kubernetes.default.svc, Kubernetes.default.svc.cluster. All sorts of these short names that we use for internal DNS and service discovery inside the Kubernetes cluster, as well as the IP address that we're using externally. And if I were to actually tying this to a domain name, I'm not doing that in this example, but if I were tying this to a domain name, I'd have to put the domain name in there as well. So go ahead and generate this certificate for our Kube API server. Done. And then the last thing, I think this is the last thing. Yeah, the last certificate that I have to create is for our service account. So service accounts are incredibly useful tools inside Kubernetes for things doing other things. It's used extensively across in the RBAC implementation inside Kubernetes. And to sign all of those, when you create a service account, it has a certificate associated with it. It gets signed. So we verify that with the certificate that we're creating here. Done. And then SSL generate cert. Oh, all right. Now, just taking a quick look, I've had to create, there are this many. Looking at all of these, there's a certificate and a key for each worker for the kubelet, a certificate and a key for the service account, for the Coupe Scheduler, for the Kubernetes API, for Coupe Proxy, and the Coupe Controller Manager, along with the certificate authority that we created to sign all of them. All of these are 2048-bit keys, all of them randomly generated and signed by the same certificate authority. All of this has to happen every time you deploy a Kubernetes cluster. There's a lot of work that goes into deploying Kubernetes that we've automated away. It's pretty awesome. So the last thing we're going to do in this lab, distributing the client and server certificates. So we're going to take to our server, our application nodes, we'll put the certificate authority key, the certificate authority PIM file, the certificate authority key, sorry, the CA cert, the instance, so the key and the cert for each instance, and SSH them over using Gcloud, or SCP them over using Gcloud. Been talking for 40 some odd minutes and my mouth is a little tired, sorry. So we'll see all those files get moved over. And then for the control plane nodes, we'll move over our CA key, because we didn't put the key on each node. The key only belongs on the control planes, as well as the CA certificate, the API server key, the API server certificate, the service account key, the service account certificate. And we'll move the schedulers and everything. We'll move all those over in another lab. All right, those are all done. Or they're finishing up. All right. And that's everything. So we're about 50 minutes in. Yeah, we're about 50 minutes in. Again, just bringing up the docs page for a minute. I know there's a lot of it. That feels like a really sort of anticlimactic start to deploying Kubernetes. Um, it feels a little weird that all we did was spin up some VMs and create a VPC, which is kind of boring, and then create a bunch of TLS certificates and shuffle them around. I know that feels a little weird, but I think it's pretty important to sort of understand the fundamentals of that's how Kubernetes works. Like there's a ton of encryption flying around, and there's a ton of verification that the encryption is proper. Every service in the control plane is going to be encrypted using 2048-bit encryption. All communications to the control plane from our nodes is going to be encrypted using 2048-bit encryption. And we just did the work to make sure all of that happens properly. It's pretty cool. At least I think it is. That's the work that we've got for this week. If we take a look at next week, the work that we're going to be doing is just waiting for the screen to pop up. So we'll actually create the kube config files. And one of the things that it never really, again, and because I hadn't done this in probably 2 years, I'd forgotten. One of the really cool things is all of the configuration files inside Kubernetes. So all the config files for all of the services are actually created using the Coupe Ctl command, which is kind of cool. So we'll create all the config files for all of our different services. We'll set up data encryption and then actually configure etcd. So we'll go on to those control plane nodes and configure an HA etcd deployment and make sure that's working. That's what we've got on tap for next week. It'll probably be next Tuesday. It may be next Monday. I haven't quite got that scheduled out yet. But that's what we've got for this week. It came in right at about 50 minutes. If you've got any questions, there aren't any questions in the chat. But if you've got questions, hit me on Twitter or hit me on email. I'm pretty easy to find. And good luck. Thanks a lot.